a lot of time helping in the forcings task team more broadly, get data out and get us ready for publishing data to ESGF. So I've spent a bit more time thinking about that. I'll talk about that a little bit, and then slightly less time thinking about greenhouse gas concentrations, which you'll see in the balance of the presentation as well. So yeah, I obviously didn't do this by myself. I get a lot of support from Malte Meinshausen, who's also at Climate Resource, and then Paul Durack and the rest of the CMIP7 forcings task team play a huge role as well. So yeah, we're doing this work through a company called Climate Resource. So we obviously do science stuff, and then we have a big research software engineering arm, and that's how we're helping out with a lot of the tooling and other bits and pieces that we're building for input for MIPS, and then also for CMIP7 more broadly. So today there's three things I really want to talk about. So one is that data is available that you can go and play with. Two is a little bit of a reminder of how to keep up to date with the wider input for MIPS progress and where we're up to there, and some updates from the forcing task team more generally. And then three, I'll do a little bit of going into what's new in the CMIP7 greenhouse gas data, how it differs from the CMIP6 stuff. These slides are both for this presentation, but they're also meant as a reference. So there's actually quite a lot of information in them. If it feels very fast, then it's kind of meant to, but that means all the information is there if you want to go back and look at things or find links, etc. And I think we'll probably put this up on, I don't know, Zenodo or somewhere else, Beth, so that people can find it again later if they need to. So getting started, the first and most important thing is that data is available. And so this is prototype data. The idea is that we want to get the data into data users' hands as quickly as possible, so we can then iterate on it, and we can do those iterations fast and early, so that when CMIP7 rolls around in early 2025, when we flick that switch, everything's as smooth as possible, and we've caught as many issues as possible as early as possible. So you'll hear this message a lot, but please, if you're a data user, go and try and use it, go and grab it, see how it works, see if what's wrong with it, and then give us feedback so we can make that feedback loop as tight as possible and catch as many things as possible before we start having to run final CMIP7 simulations. In terms of getting the data, there's a few places. So one is the ESGF search interface, which I'm sure you all know very, very well. A second one that I can really recommend is a tool called ESG Pool, which is developed out of one of the French institutes. I think the institute who maintain the IPSL model, but someone can correct me in the chat. I've used this tool and I found it really, really helpful. I think the docs are really nice. They have good installation instructions. There's an extra setup step, which isn't typically used normal for Python stuff, but it's pretty straightforward. And then the only trick I found is if you want to grab input from MIPS data, you need to point your ESG pool instance at the LNL node rather than the default is the IPSL node, which doesn't have any of the data for input from MIPS on it at the moment. And the reason I really like ESG Pool is that once you've installed it, grabbing the data is really trivial, and you can also track all of the scripts you use to grab your data, for example, in Git, which makes sharing them really easy, and it makes it really easy to think, okay, how did I actually get this data? What did I search for? What did I grab? What did I not take as well, which is going to be important because not all models need all data. So for example, with our greenhouse gas concentration data, if you just want to grab all the global mean, annual mean data, you can use a search like this. And ESG Pool has this workflow where it's basically like add, update your search, and then download. So I've done this just before, and it's super simple, super straightforward, and really nice. If your group is a group who needs, this is so-called option 2 from Meinshausen et al. 2017. So you need CO2, methane, N2O, CFC12, and then everything else you capture in this CFC11 equivalent species. Then you could do that search like this, which is relatively straightforward once you've seen it, but trying to communicate this in a way without just saying, here's the command, I think would be relatively tricky. And for example, if you're a group who wants the 15-degree data rather than the global mean data, you can change the grid level you're searching for. Otherwise, the commands don't change. You might want different equivalent species, for example, which is what I've done in this example. And then you can grab the data again. So I can really recommend ESG Pool. I think it'll make all of our lives a lot easier in terms of knowing what data we want, making sure we only get that data, keeping track of how we got it, and just making all of our lives a bit easier in terms of understanding where everything comes from. If you don't want either of those two options, someone might just give you the data. That's actually not as bad an option as it initially seems. And the reason is that every file we produce for input for MIPS has this unique tracking ID. And so even if you have no idea where you got the file from, we can always look at the tracking ID and work out which file it is, which is pretty helpful and means that actually just handing it around on USB sticks, as much as not recommended, isn't as much of a disaster as you might initially think it was. And then obviously there are probably other options which I don't know about. But the key takeaway from all of this is that feedback is really welcome. It's actually something we would really, really benefit from. We can't catch everything ourselves and we only bring one lens to our data. So we need that feedback from others. And there's a couple of ways that we want to get that feedback ideally. Number one is on via GitHub. So there's this input for MIP CVs repository. And the idea there is that we want everything to be public so that we can have public discussions. If there's someone else who's had the same issue, you can find it and we can cross-reference them. Option B is email, but I'll give a heads up now that if you email me, I'll be making an issue on GitHub. So if you don't have a GitHub account, make one, because that'll help everyone share the knowledge and get all of this in the public domain and out of our inboxes, which is where it's tended to get stuck in previous iterations. So on input for MIPS more broadly, we've got, sorry, just checking my notes. So where we're up to is we're basically preparing and publishing data sets as quickly as we can. We're attempting to make our data and our metadata as consistent and straightforward to navigate as possible. Now, this does introduce some changes from CMIP6, but we think they're generally good changes. And on top of that, if you have any comments, questions, there's things that you'd like to have documented, there's things you don't understand, then as I said before, like, please get in contact. So the issue's in the same place, and then there's a few different emails here. So emailing Paul Vishali, who's the co-lead of the Forcing Task team, or myself, and then we can help direct you in the right direction. At this stage, as I said, feedback is incredibly important. That's really the key for us ironing out as many issues as possible and building up a shared knowledge base that will help all of the CMIP data users in this next iteration. In terms of navigating the data, there is a method to the madness, but it does take a little bit of time to get your head around and a little bit of engagement to figure out. So one example of this is that directories and files are named in a very specific way, and that allows us to keep track of their metadata. And that's captured in a very specific JSON file in this example. The point of this is that, like, everything should basically be machine readable and machine processable and documented. So if it isn't, then, as I said, please get in contact to help us prioritize the things so that we know what users want and what they're struggling with, and we can fix that as quickly as possible. And this is the same contact information as the previous slide. If you want to keep up to date with where things are up to with input for MIPS, then there's a couple of different views. This is the uglier but latest view, which we maintain through our input for MIPS repository. So one of the things you can see here, if you look very, very closely, is that we've actually got data published for 3 of our data sets. We expect to get data published for another 4 in September, hopefully early September, which would then mean we've only got left data sets which depend on other data sets in our set. So we nearly have a full set of independent input for MIPS data, and then we hope to have the full set by early January next year in a V0. So I think we're moving at a reasonable pace. Obviously, the CMIP7 timeline is tight, but we are getting there. And if you want to keep up to date, then this is a good link to bookmark. There is a slightly nicer view, which is maintained by Eleanor and the CMIP IPO team on their task team's Forcings website. The information is the same, so you can take your pick which one you want to go with. Okay, and then just before I move on, so yeah, they've got their status pages. And as I said, if you're confused or something doesn't make sense, please raise an issue, because that's really the key for us ironing out the kinks and getting everything running smoothly. So in my last 4 minutes or so, I'm going to give you the very, very short overview of CMIP7 versus CMIP6. This will be very quick. As I said, I haven't dived into this myself yet as much as I would have liked. So there's still a bit of work to be done here, but it'll give you a flavor of where we're going. So the first thing is that we're trying to use the same methods as CMIP6, but we've had to completely rewrite the code. So there's a few kinks that we're ironing out. In general, we're using the same observational networks, and these teams do a heap of work, and they should get more credit, and as much credit as we can give them. So for example, there's this gauge network, which does observations of a whole bunch of gases. I'm showing here their observations of C2F6 and where those stations are and kind of how they look over time. Then we also use the NOAA network. That's a really big source for us. And so they've got a whole bunch of observations of methane, CO2, nitrous oxide. You can see their network is slightly more extensive, and they also do shipboard measurements, which we try and capture as well. So they give us another really important data point. And there's a whole bunch of other observing networks off the top of my head. For example, the Law Dome Ice Core network, which is maintained by CSIRO, is a really important one for us. And then we try and pull all of this together. So when we pull it all together, we still produce latitudinally, seasonally resolved data. These are these so-called flying carpets, and they're called that because when you plot the data on this 3D grid with time, latitude, and then the value, it sort of looks like a flying carpet. So you can see both, this is for methane, both the latitudinal gradient, and then also the seasonal gradient comes out. And then from this, we create our global means, our hemispheric means, and our annual means. And for most gases, people seem to generally be interested in global, hemispheric, and annual means. But for methane, the conversations that we've had with a few groups suggest that actually the seasonality and the latitudinal gradient might be quite helpful too. So that data's there if you want to go and play with it. If we actually look at the differences between CMIP7 and CMIP6, then for CO2, it all looks pretty stable, which is good. Very few differences from the previous iteration. We just can extend out now to the end of 2022. Methane is a very similar story. There is a difference of 10 to 20 parts per billion pre-1950, which I need to go and investigate a bit more. I'm not actually sure what is causing that, but overall it looks relatively similar. So if your models were happy with the CMIP6 methane, they should be relatively happy with the CMIP7 methane as well. N2O is a similar story to methane. There's actually a bit of a funny jump happening between 1750 and 1850. Now, historical CMIP simulations, that's not really an issue, but if you're doing earlier simulations, you might care about that more. And then one more gas, which is CF12 to look at. So here there's this extrapolation algorithm we've used to go from 1975 or so back down to pre-industrial, so 1950. And there's clearly a difference in the algorithm between CMIP7 and CMIP6, which we need to go and investigate a bit more. And then here's an example of something that's really not worked. So something's gone wrong in our CFC11 processing. So if you're using this data, just be aware of this. Well, this is our CFC11 equivalent species. So this is the kind of thing which we're hoping to catch sooner this time around. And your feedback is a really critical part of that. So again, if you're giving feedback, GitHub, through the issues, or email us, and then we can move it into GitHub and help you get onto that platform. And yeah, if you want to go explore yourself, all the code that made the plots you've just seen is at this URL. It might help you with seeing how to use ESGF pool, how to plot the data, how to deal with some of the quirks and the differences between the two iterations. So trying to wrap it all up. If you only remember one thing from this, it's that the first version of the CMIP7 greenhouse gas concentrations is available now. Please go and try it out and give us feedback. That's a really important part of the process. Don't start your final simulations on this. It's a test data set, and there are bugs and there will be bugs, and we're going to get rid of as many of them as possible before we do get to final simulations. Here are the key feedback links. So as I said, GitHub and email. And then from the overall picture, data's available. You can keep up to date with the latest forcing releases via our website, where we're trying to keep up to date with when things are being released and when they're expected to be released. And then CMIP7, the greenhouse gas data, will go through iterations over the coming months. And so we're aiming to be ready for simulations early next year. So I will stop there, leave those links up, and then I guess pass back to Beth to moderate questions.
Great. Yeah, thank you so much, Zeb. That was a really excellent overview of kind of where the forcings are at and what people can do with the data. Have we got any questions? Feel free to either pop one in the chat or pop your hand up. Perhaps while people are just thinking, quite a broad question probably, but I wondered if you had any sort of first guesses on what was going wrong on that. Was it the CFC, the final one you showed for the CFCs?
Yeah, when I convert from, to do a conversion from the raw gas into radiative forcing and then back out, And I think I will have just mucked one of those conversion factors or got a 1/over factor wrong somewhere. That, or there was a big bug in the CMIP 6 version, which we've now fixed, which is also possible, but I hope isn't the case. Anyway, it'll be one of those two.
Cool, thank you. Have you got any other questions for Zeb? Not seeing any hands for now. Perhaps if you think of any throughout the rest of the seminar, feel free to pop them in the chat, and Zeb, perhaps you can check and answer them in there if any do come through. And yeah, as he said earlier, we'll have the videos from the seminar available on YouTube and on our webpage, and we'll try and get the slides up there as well, or a link to the slides, so that you can access the links that were presented today. So thank you again so much, Zeb, for that really great presentation.
Perfect. Thanks, Bess.